just using a different method to find the hydronium and hydroxide ion concentrations. So the first method I taught you was to use the KW equation. That's assuming that you have one of the concentrations to begin with, and you know the substance. What happens though if you're only given a pH or a pOH? So in that case, you have to first find the pH and the pOH. You're going to use the pH and the pOH in these two equations. So H3O plus equals 10 to the negative pH, or OH minus concentration equals 10 to the negative pOH. And then if you want to, you can always use the KW equation to check your answers, because when you multiply the two together, you should get the value of KW. So let's try this out. Okay, an HCl solution has a pH of 3.3. So find the hydronium and the hydroxide ion concentrations. So this is an acid, so the pH makes sense. So once again, I'm just going to make a list on the side here. Okay, so I know the pH, and I have to give you one of these. So that takes care of pH. Now I can use this equation to find pOH. I don't have any other option. Okay, so subtracting 14 minus 3.3, I get my pOH of 10.7. So far, so good. It makes sense to have a low pH and a high pOH for an acid. Now I can use these equations, doesn't matter which one first. I'm just going to do the hydronium ion concentration first. So that's equivalent to 10 to the negative pH number. So 10 to the negative 3.3. And you do have to solve that. You can't leave it in that equation. And you're always going to get a number raised to the times 10 to the power. So your calculator may present this to you in a weird looking way on your calculator. If you have a question on how to interpret that answer, just get a hold of me and I can show you. Okay, so 10 to the negative 3.3 power gives me a hydronium ion concentration of 5.01 times 10 to the negative 14th with a unit. And then I'm going to use this equation to find my OH minus concentration. Quicker than using the KW equation. Let's type into your calculator. So my hydroxide ion concentration is equal to 10 to the negative OH. So once again, you have to solve that, so plug in your calculator. And I get that my OH minus concentration is 1.99 times 10 to the negative 11. Oops, and I made a mistake, I'm sorry. My hydronium ion concentration is just to the negative 4, not the 14th. Hopefully you caught that and you're like, what the heck? Okay. So we've already verified that these two equal 14. But if you wanted to check these numbers, multiply them together, and you should get that KW value. Also, the hydronium ion concentration is a bigger number than the hydroxide, which makes sense for an acid. So these are my answers. You had to find pH, which was given to you. Therefore, you had to find pOH to solve for the rest. So once again, make sure you're looking at what's being asked of you, because there are different methods for solving. Okay, let's try another one. So NaOH, which is sodium hydroxide, a base, has a pH of 11.1. Find the hydronium and the hydroxide ion concentrations. Check your answer. Make my list, because I like to be tidy. The only thing I know right now is pOH. Okay, so step one, I'm going to use this equation to find pH. Oh my gosh. Guys, I'm losing my mind. Did you catch all my mistakes? I'm so sorry. It says the pH is 11.1, not the pOH. Let me fix it. Okay, pH is 11.1, which makes sense for a base. So I'm going to use this equation to solve for pOH. My apologies. I always need to read carefully. Okay, so 14 minus 11.1 gives me a pOH of 2.9. Now I can use either equation to solve for the hydronium and hydroxide ion concentrations. So I'm going to start with this one first. Doesn't matter which one you start with. What does matter is that your pH and your pOH are actually correct. So 10 to the negative 11.1 gives me a hydronium ion concentration. One times 10 to the negative 11 molar. And then my last step is to solve for the hydroxide ion concentration, or vice versa if you did it the other way. It doesn't matter which one you do first, as long as you use the right numbers. So my hydronium ion concentration is solved for. My hydroxide ion concentration is equal to 1.26 times 10 to the negative third molar. And once again, you can check your answers. Multiplying those two together should give you the value of Kw. All right, try one more on your own. So once again, find the hydronium and hydroxide ion concentrations of a substance whose pH is 4. So it doesn't tell you what the substance is, but you assume it's an acid based on the pH. So go ahead, pause the video, and see if you can solve it yourself, and then come back and check your answers with me. Okay, so check your answers. I have my pH of 4 given to me in the problem. I used this first equation, which isn't up here, which is weird. To solve for pOH, pOH is 10. Then I used this equation first to solve for the hydronium ion concentration. And then I solved for my hydroxide. It doesn't matter the order in which you do those two. Once you have pH and pOH, it does not matter which one you solve for first as far as concentration. And then once again, multiplying those together should be Kw. So this is using a pH and a pOH only to find the hydronium and hydroxide ion concentrations. I do not have a concentration to use the Kw equation.